Welcome to my presentation, The Constructed Reality of Data, Rethinking Classification, Induction, and Digital Ontologies. My name is Peggy Bloomer, and I am an assistant professor of art and design at Central Connecticut State University in the United States. This paper explores how classification systems, whether in scientific taxonomies, algorithmic infrastructures, or everyday discourse, shape and constrain our understanding of the world. While these systems serve organizational purposes, they often enforce rigid boundaries that obscure the fluid, contextual, and evolving nature of knowledge and experience. In design thinking, politics, and even casual conversation, we need frameworks that allow for greater nuance, emergence, and adaptability. John D. Norton's material theory of induction provides a vital foundation for this argument by challenging the assumption that inductive reasoning follows universal schemas. Instead, Norton posits that inductive logic is justified by local material conditions, highlighting the epistemic limitations of applying fixed models to dynamic realities. To move beyond reductive categorization, this paper draws on a philosophy of individuation, particularly the work of Gilbert Simondon, who conceptualized technical objects and imagination as co-evolving with their associated milieus, and the medieval scholastic thinker John Duns Scotus, whose notion of heteity, thisness, foregrounds the irreducible singularity of beings. Together, these frameworks invite us to reconceive digital ontologies and classification not as fixed hierarchies, but as adaptive, individuating processes, capable of supporting more ethical, pluralistic, and context-sensitive ways of knowing and designing in a digital age. John D. Norton's material theory of induction challenges the conventional premise that inductive reasoning follows fixed, universal laws. Instead, Norton argues that induction is grounded in specific material facts and situated local contexts, not abstract generalizations. This insight destabilizes the foundations of classification systems based on universal schemas, particularly those prevalent in artificial intelligence, predictive analytics, and standardized data science, which assume that knowledge can be cleanly abstracted from its conditions of emergence. These systems often fail to account for the fluid, contingent, and evolving nature of epistemic life. Exacerbating this issue are the static ontologies embedded in algorithmic infrastructures. As Jeffrey Bowker and Susan Lee Starr observe, classification frameworks tend to ossify historical power structures, reinforcing dominant narratives under the appearance of neutrality. Wendy Hui Kyung-chun further extends this critique by showing how algorithmic correlation often reanimates eugenicist assumptions under the guise of scientific objectivity. These processes do not merely misclassify, they actively reproduce social inequalities by masking bias as rational structure. Taken together, these critiques call for a more relational, adaptive, and reflexively critical approach to knowledge organization, one that acknowledges material specificity, contextual nuance, and the ethical implications of epistemic design. The philosophical debate between individuation and universals is rooted in the work of John Duns Scotus, who argued that a being's common nature cannot be entirely separated from its individuality. His concept of hequity, or thisness, frames individuation not as the absence of generality, but as an irreducible singular unity, a unique instantiation of being that resists full subsumption under abstract categories. Rather than being an exception, hexiety expresses the ontological distinctiveness of each existent. Gilbert Simondon advances this perspective by rejecting the notion of fully formed static beings. For Simondon, individuation is an ontogenetic process, a continuous becoming, in which beings emerge through metastable tensions and the negotiation of interior and exterior conditions. His notion of the associated milieu emphasizes that technical and social systems co-evolve with the entities they produce, while transduction describes the recursive restructuring that drives this emergence. Individuation is thus not a finished identity, but an unfolding relation that seeks to resolve the tensions that are present in any system, whether political or aesthetic, biological or cultural. Building on the philosophies of Simondon, Yuck Hui further develops these ideas through his theory of relational materialism, arguing that digital objects are not self-contained entities, but arise through metadata, protocols, and contextual relations. In digital environments, data is not neutral or inert. It is dynamic, historically situated, and culturally encoded. This radically challenges static classification models and compels us to reimagine digital ontologies as processes of becoming rather than mere systems of categorization. Repetition in contemporary data systems, especially in predictive algorithms, often leads to the reinforcement of historical patterns rather than the generation of new insights. Practices such as predictive policing draw from past crime data to anticipate future behavior, inadvertently codifying systemic biases and perpetuating existing social hierarchies. This over-reliance on repetition creates a feedback loop that privileges what has already been observed, thereby stabilizing entrenched power structures and limiting the possibility for transformative change. In contrast, philosophers like Gilles Deleuze and Gilbert Simondon propose a theory of difference as productive rather than deviant. Difference, in their view, is not a departure from an established norm, but the generative force that drives individuation, the ongoing relational process through which entities come into being. This ontological reorientation disrupts the logic of fixed categories and opens conceptual space for emergence, novelty, and transformation. Recognizing difference as foundational has ethical as well as epistemological implications. It affirms the value of pre-individuated states, those that have not yet been captured or delimited by formal classification. To honor these states, data systems must be dynamic and reflexive, capable of accommodating evolving identities and contexts. Such responsiveness is critical to building just and equitable infrastructures of knowledge that support becoming rather than enforcing static norms. Building on the ethical and ontological critique of repetition and static classification, we now turn to concrete case studies that demonstrate how these theoretical concerns materialize in real-world systems. From policing to image recognition to causal inference, contemporary digital infrastructures illustrate the consequences of privileging universality and repetition over contextual specificity and difference. These examples not only expose the limitations of current approaches, but also suggest how a shift toward individuation and relational thinking can inform more equitable and adaptive practices. Predictive policing, as analyzed by Ben Bouzid, exemplifies how algorithmic classification reinforces surveillance infrastructures. By relying on historical crime data, these systems perpetuate racialized and class-based assumptions, failing to register emerging social conditions or contextual nuance. Rather than supporting reform, such systems calcify past injustices and amplify systemic bias. They do not respond to the evolving realities of urban life, but rather preemptively target marginalized communities based on inherited patterns. Benchmark datasets like ImageNet further illustrate the pitfalls of fixed taxonomies. Relying on essentialist labels, these datasets embed cultural and epistemic biases into the very structure of machine learning models. What appears to be neutral labeling is, in fact, a political and cultural encoding that shapes the way machines see the world. These rigid categories obscure complexity and reinforce normative assumptions about identity, function, and value. A shift toward metadata transparency and dynamic tagging, where labels can evolve and be questioned, would enable a more responsive and ethical digital infrastructure attuned to context and change. Judea Pearl's work on causal inference underscores the danger of confusing correlation with causation in AI. Systems trained purely on correlational data lack the capacity to infer why phenomena occur, which limits their ability to adapt or predict meaningfully. By embracing material individuation, where causality is understood as emergent from specific situated relations, we open the door to more robust, adaptive, and just forms of machine reasoning that better reflect the complexity of the real world. To address the limitations of fixed classification systems, we must shift toward reflexive, context-sensitive frameworks for data ontology. John D. Norton's material theory of induction offers a foundation by emphasizing that knowledge production is materially grounded and locally justified. Simondon's philosophy of individuation deepens this by revealing being as a process, constantly becoming within and through its milieu. Yuk-Hui extends this to the digital domain, proposing that data objects are not discrete units, but relational entities shaped by cultural, historical, and technical contexts. Yet Hui's framework of cosmos technics invites us to go even further. In contrast to universalized technoscientific rationality, cosmos technics proposes a pluralistic approach to technology, one that is embedded within the ethical, cosmological, and ontological orientations of particular cultures. This means that digital systems should not only reflect local material conditions, but must also resonate with how different societies understand life, knowledge, and becoming. Designing classification systems through the lens of cosmos techniques would encourage technologies to be not just efficient but meaningful, capable of supporting forms of life that are diverse, situated, and ecologically entangled. Practically, this means embracing epistemic uncertainty as an inherent feature of digital systems rather than a design flaw. Classification schemas must accommodate dynamic annotation, allowing for revision and reinterpretation over time. Systems should be designed not as static repositories of knowledge, but as evolving structures responsive to emergent social and material realities. When aligned with cosmos technical thinking, such frameworks do more than reorganize data. They participate in world making. They help cultivate infrastructures that are not only technically robust, but also ethically attuned to the plurality of ways of living in and with the world. Static classification systems obstruct the recognition of essence and potential by imposing reductive universal schemas that fail to engage with the fluid, emergent nature of beings and data. Grounded in the critique of epistemic rigidity, this paper has argued for a shift toward systems of knowledge and design that embrace individuation, contextual materiality, and relational becoming. Drawing on John D. Norton's material theory of induction, Gilbert Simondon's ontology of individuation, and Yuk-Hui's relational and cosmotechnical philosophy, we have seen how data and classification are not neutral tools, but ontological interventions that shape both perception and possibility. The call is no longer simply for more accurate or inclusive classification systems, but for ontologies that evolve with the world rather than presuming to order it from above. If classification shapes what can be known, valued, and acted upon, then designing epistemic infrastructures must become a cosmopolitical endeavor, an ethical engagement with the plurality of worlds and ways of being. Yuk-Hui's theory of cosmotechnics offers a compelling pathway here, as he writes in Cosmotechnics as Cosmopolitics. Cosmotechnics is not merely about applying local knowledge systems to global technologies. It is about rethinking technology as part of a broader cosmological order, where technical activity is bound to a people's understanding of harmony, ethics, and the cosmos itself. It rejects the colonial universalism of Western techniques and instead proposes a cosmopolitics, a politics grounded in coexistence among divergent cosmologies, rather than assimilation into a single rational system. In this light, classification becomes not a matter of efficiency or taxonomic precision, but of ethical, and ontological responsibility. Systems should be designed with the capacity to recognize difference not as deviation, but as potential, as a sign of worlds still in the making. Pre-individuated states, as Simondon would say, are not errors or data noise. They are the fertile ground of future transformations. To ignore them is to calcify injustice. A cosmopolitical framework for data ontologies calls us to design systems that are reflexive and revisable, open to reclassification as social, cultural, and environmental contexts evolve. Embed material and cultural specificity into classification logic, allowing technologies to reflect diverse cosmologies rather than a single worldview. Embrace epistemic humility by acknowledging the provisional nature of all knowledge structures and the ethical consequences of their deployment. Shift from seeing technology as a tool of control or prediction to seeing it as a participant in ontogenesis and world building. If digital systems are to be not merely tools of administration, but architectures of possibility, then we must learn to think with multiplicity, live with uncertainty, and build with care. The future of data ethics and of planetary cohabitation depends on our ability to move beyond universal classifications and toward individuating, cosmotechnical infrastructures of thought and relation.